Very good morning, all. Today, we are going to solve a problem of two power plant economic dispatch of two power plants. Take on this problem. A system consists of two power plants connected by a transmission line. Yes, the total load located at the plant is shown in the figure. The data for evaluating the loss coefficients consists of information that power transfer of 100 megawatt from station 1 to station 2 results in the total loss of 8 megawatt. Find the required generation at each station and the power received by the load. So power received by the load is demand. Required generation at each station is PG1 and PG2. By the load, when the lambda of the system is rupees 100 per megawatt hour. The incremental fuel cost of two plants are given by DC1 divided by DPG1 is equal to 0.12 PG1 plus 65 rupees per megawatt hour. Next, DC2 divided by DPG2 is equal to 0.5 PG2 plus 75 rupees per megawatt hour. And that figure also given here. So here generating station 1 that is connected to bus 1. Then the generating plant 2 that is connected to bus 2. So in between the transmission lines are there. So the load we are taking out at plant 2. That is this bus number 2. Now it's a very simple problem. So by seeing this problem itself, so clearly they given data for evaluating loss coefficient. So this problem in the losses also that we need to understand before solving the problem. Then further we need to losses problem. So the solution goes like this. So the power loss equation PL is equal to PG1 into PG2 into B11, B12, B21, B2, PG1 to PG2. So this you need to multiply. So you need to multiply this 2 and again with this 2. Since the load is at the bus 2, PG2 will not have effect on PL. So here just if we multiply, we'll get the equation like this. That is B11 PG1 squared plus 2 B12 PG1 into PG2 plus B22 into PG2 squared. So if you forget also once you multiply and see, so this same equation will. So here since the load is at bus number 2, so PG2 will not have much effect on PM. Okay, so that's why what we are doing is we are neglecting this PG2. So PG2 we are neglecting, PG2 we are neglecting. So only this PG1 alone we are taking. So PL is equal to loss coefficient equation. PL is equal to B11 PG1 square. Take this as equation number 1. So substitute now PG1 is equal to 100 megawatt because in the problem itself the data is given. The data for evaluating loss coefficient consists of information the power transfer from the power transfer of 100 megawatt from station 1 and station 2 is given. So in this problem we can clearly understood like 100 megawatt is transferred from station 1 to station. So PG1 we are taking this 100 megawatt for calculating the loss coefficient. So further simplification we'll get B11 as a BW1 as 0.0008 megawatt inverse. Okay, megawatt inverse. So this megawatt inverse, how it comes means the previous formulation already I have explained you well that you once you please refer. Next, substitute this B11 in the equation number 1. Equation number 1 we get a PL as a 0.0008 into PG1 square. Now we need to multiply with we need to differentiate this dou PL divided by dou PG1 is equal to this 0.0016 PG1 because this will comes here. So into 2. So into 2. So it will become 0.0016 PG1. Now the condition for optimal dispatch. What is the condition for optimal dispatch? L1 into DC1 divided by DPG1 is equal to L2 into DC2 divided by DPG2 is equal to lambda. That is the condition for optimal dispatch. Take this as equation number 2. So this since PL is a function of PG1 alone, so here we are calculating L1. So L1 is equal to 1 divided by 1 minus dou PG, dou PL divided by dou PG1. And similarly, so dou PL divided by dou PG1 already we calculated. So that okay, that formulation we back here. So that is dou PL divided by dou PG1 is equal to 0.0016 PG1. Similarly, this L2. So L2 is equal to 1 minus, 1 divided by 1 minus dou PL divided by dou PG2. So, so here PL is only having PG1 alone. So if you differentiate with respect to PG2 also, it is becomes 0. So this part becomes 0. So L2 is substitute 1 divided by 1 minus 0. So again it is 1. So L2 is equal to 1. So now the condition for optimal dispatch, now we are substituting uh, this L2 as 1 and L1 already we calculate 1 divided by 1 minus 0.0016 Pg1. Next DC1 divided by dPg1 already given in the problem. So DC1 divided by dPg1 already given in the problem. Just we are substituting here. Next we are substituting here. So it will become 0.12 Pg1 plus 65. Next L2 we are substituting as 1 and this part also given in the problem 0.25 Pg plus 75. So is lambda also given in the problem. Lambda is given in the problem as 100 mega 100 rupees 100 per megawatt hour. So that lambda also we are substituting over here. So lambda. So now we need to calculate what is Pg1 and Pg2. So this part alone equating it to 0, this part alone. So what we can do is, so this as it is you will be writing, this part is 1 minus 0.0016 into Pg1. This we are taking to this side. Actually, if you multiply this, it will become a complex equation. It is very difficult to solve. So best thing is to multiply this alone, this part to this side, taking this part to this side. So multiplying this one 0.12 Pg1 plus 65 is equal to 100 minus 0.16 into Pg1. So again, further simplifying, this goes to here. So 0.28 Pg1 is equal to, this goes here. So 100 minus 65 is 35. So Pg1 is 125 megawatt. Similarly, this part alone equating it to 100. 100. So if you equate it to 100, it will give Pg2 is equal to 100 minus 75 divided by 0.2. If you simplify this, Pg2 we got it as 100 megawatt. Now Pg1 we got, Pg2 we got, PL we need to calculate, losses we need to calculate. So what is PL? So here PL we calculated already. So PL is equal to, yeah, B11 into, so PL is equal to, yeah, here B11 into Pg1 square. So that is equation number 1. Substitute in this equation number 1. So PL we will get. So PL is equal to 0.008 Pg1 square. So Pg1 we already calculated is 125 megawatt. That we are substituting over here. So 0.0008 into 125 square. It will come. It will become. So PL is equal to 12.5 megawatt. So what is total demand? So what is power balance constraints? Power balance constraints is generation is equal to demand plus loss. So generation is here only two generators given. So Pg1 plus Pg2 is equal to PD, demand plus losses. So demand PD, demand plus loss. So we need to find out the total load. Total load or demand. Everything is same. So total load or demand. So this side we are taking. So PD is equal to Pg1 plus Pg2 minus PL. So Pg1 we calculated, Pg2 we calculated, and PL also we calculated. Just substituting, you can easily find out the total load or demand. Total demand. That is PD is equal to 212.5 megawatt. So this is the answer for this particular problem shown in the okay. So they asked find the required generation at each station PG1, G2, and the power received by the load. That is nothing but demand, or otherwise P load, whatever you can take. So sometimes we can take power demand, sometimes we take P load also. Everything is same. So this is the answer for this particular. Thank you.